Greetings of the day, dear students. In this video, we are going to discuss about the important characteristics of the battery. What are the important characteristics we have to consider while selecting a battery, like its chemistry and the battery capacity, which will be expressed in ampere hour, and also about its voltage and cold cranking amps. These are the four parameters, some important characteristics we used to consider, right? Now, these characteristics will be helpful to identify the identify a battery that can help to identify for which application it can be useful or applicable. The three main ones are its chemistry, the battery capacity, and voltage, right? So here, with respect to the chemistry, the main battery chemistries are, as we have discussed in our primary cells and secondary cells, it will be of having lead or nickel or lithium. Nickel, lead and lithium. Now, depending upon their chemistry, they need a separate designated or specified charger for their charging purpose, because these batteries cannot be charged on different chargers, right, which may differ on their current rating. The charging current required in order to charge the battery may depend upon the chemistry of the battery and its potential, all those things, on all those factors it will depend, right? So while charging a battery, depending upon its chemistry, for a specified charger is to be used in order to charge the battery. Next one is the battery capacity. So here the capacity of the battery, actually we will measure in a ampere hour, Ah capacity, Ah rating of the battery. So how do you understand that Ah capacity? For example, ampere hours. For example, if you are having a 12 volts and 7 Ah battery, then its meaning is, if on this battery, for example, if you are having a battery like this here, some positive negative, which is having a capacity of its rated voltage is 12 volts, but ampere hour capacity is 7 Ah, right? On this battery, if you have connected a load which works on some 12 volts, a load which works on 12 volts, right? But if its power rating is some 24 watts, if its power rating is 24 watts, then obviously this battery is going to this load is going to draw a current which will be equals to the, for example, the current drawn will be equals to the power rating divided by voltage. In this context, it is some 24 watts divided by 12 volts. It is going to draw 2 amps. So for this load which works on some 12 volts voltage and 24 watt power rating, if you connect this load on this battery, this load is going to draw a current of 2 amperes. This load is going to draw a current of 2 amperes. Now, if the load is keep on drawing a current of 2 amperes, for how much time period this battery can serve the load? That is important. For how much time period this battery is going to serve the load? It cannot serve the load throughout the day. It depends upon its capacity. It depends upon its capacity. Here 7 Ah battery means, if you are extracting 7 amperes from the battery, it will work for 1 hour. It will work for 1 hour. On the same 7 Ah battery, if you are drawing a current of some 3.5 amperes, then this battery will work for 2 hours. This battery will work for 2 hours. But if you are connected a load which is drawing only some 2 amperes, 7 divided by 2, 7 Ah is the capacity of the battery, but the load is drawing some 2 amperes, then its meaning is it will work for a period of some 3.5 hours. It will work for a period of 3.5 hours. But it does not mean that you should completely discharge the battery. You should at some reserve capacity is to be maintained at the bottom of the battery. Instead of completely discharging the battery, which is having some positive negative, some reserve capacity is to be left at the bottom of the battery, which will not disturb the life of the battery. You should not completely extract the entire energy stored in the battery, right? Like that, depending upon the ampere hour capacity, for how much time period it can serve the load can be decided. And moreover, it does not mean that on a 7Ah battery you should not apply a load which draws some 7 amperes. So if that is the case, the entire battery gets discharged within a span of 1 hour. That much heavy load you should not apply on the battery. That much heavy load you should not apply on the battery, right? So what should be the you should not apply that much heavy load on the battery, which will get the battery discharged quickly. So here ampere hour capacity will decide you the amount of and also the voltage value. Depending upon the voltage of the battery, and ampere hour will decide the amount of energy stored in the battery. Amount of energy stored in the battery. Sometimes you can express it in watt hours, right, or kilowatt hours, or Ah is the common terminology that will be used. Ah is the common terminology that will be used, right? Now, for example, if the same battery, if the same 12 volts battery, but a 100Ah battery you are having, if you are applying load of, if your load is connected which is drawing some 10 amperes, then the battery will work for, then this battery will work for 10 hours. Like that we have to understand, right? But now if the load should get operated at some 120 volts, then 12 volts batteries cannot serve the purpose. You have to connect all those batteries in series, positive negative, such that you should get a 120 volt DC. If the single battery voltage is only 12 volts, but for an application if you require 24 volts, if the load is operating at 24 volts, then you have to connect these two batteries in series, right? Yeah. Now the voltage rating of the battery, the voltage will be specified, and also we will have a open circuit voltage which will be nominally little bit 5 to 7% higher than the fully charged battery. On a fully charged battery, this open circuit voltage will be some 5 to 7% higher than a fully charged battery. So in the sense, if it is a 12 volts battery, if you measure with the multimeter, if you measure it with the help of multimeter, it can show you some around some 13.1 volts or some 13.2 volts. Even though the battery rating is only 12 volts, right, it will show you little bit some 5 to 7% higher value on a fully charged battery. Now cold cranking amperes, every battery will be marked with the cold cracking amps, which is abbreviated as CCA. This number denotes the amount of amperes that battery is able to provide at minus 180 degree centigrade. At minus 180 degree centigrade, how much it is able to provide, how much current it is able to provide, that will be specified with the help of cold cracking amps, right? So these are the important parameters. So if somewhere if you come across the ampere hour capacity of the battery, you should understand it properly. For all our mobiles you can observe their current carrying capacity. We will be seeing like some 4000 mAh battery, milliamps. These are not in amps. Milliampere hour battery, some 3500 mAh battery, mAh battery, or some 6000 mAh battery. Like this we are observing. So how do you understand that milliampere hours battery? Like that we can observe in a reverse manner. For example, if your 4000 ampere hour battery, once if it is fully charged, if your mobile is working only for some 10 hours, if it is working only for 10 hours, its meaning is 10 hours. Your mobile is drawing a current of your mobile. For example, here there is a battery, and if you are connected your mobile, right, your mobile is having a battery of 4000 mAh battery, but on this battery it is able to work. It is getting operated after for every 10 hours. It is the battery is getting discharged fully completely. So if it is working for some 10 hours, right, its meaning is it is going to draw 10 cancel, hours cancel. It is going to draw some 400 milliamps. 400 milliamps. Of course, if it is working for 20 hours, if the same capacity, if it is working for 20 hours, how do you understand that? It is going to draw some 200 milliamps of current. It is going to draw some 200 milliamps of current. Your entire circuit board or setup is drawing some 200 milliamps of current, right? Yeah. Thank you.